Hello everybody, this is going to be on Thursday. So the first thing that I want to do is I want to say I know Easter break's coming. I'm hoping you're going to get some rest. Those of you that are behind, please use this time to kind of catch up on what you need to do. And I am going to go first of all and talk about the ISM book first. So as you can tell, my ISM book is not the neatest in the world, but what I have done is I have listed everything we've done so far, and that's where we are. And if you need to pause this video so you can write it down, you can. Right now, we're going to do chapter reaction review worksheet on page 22, and this right here is where we are. So if you opened up it said Teddy combined aluminum with copper 2 chloride, the product of copper and aluminum chloride. So the first thing that we have to do is we have to write down what our reaction is. Our reactant is the aluminum with copper 2 chloride, and that is my formula there. And then it produces copper and aluminum chloride, which is copper again and aluminum chloride. So with this, this is a single replacement. But what I need to do is I need to write it all out, and then I need to balance it, because based on the law of conservation of mass says it has to be balanced. So Cu is 1, Cl is 2, Al is 1, Cu is 1, Cl is next, right? And that is 3, and my Al is 1. So I like even numbers, so I'm going to go ahead and do 2 over here. So my Al is now 2 and my Cl is now 6. And so then I'm going to go over here next, and I want to change my Cl to 6. So I'm going to do a 3 in front of here. That would make this right here 3 times 2 is 6. That would change my Cl, and now my Cu is now 3. Okay, and then my Al is 1. Well, I have 2 over here, so if I put a 2 in front of here, that changes that to a 2. But then I have a problem with my Cu, because my Cu is 3 over here, so I need to put a 3 here. So after I got that done, that is the balancing for that. So that's question number 1. Question number 2 says identify the reactant and the products for this chemical equation. So I'm going to go ahead and write it out. Cu plus O2 yields CuO. And then it asks me for the reactant. And remember, my reactant is Cu plus O2. And then it asks me for my product. Which is CuO, but first I need to see if it's balanced. Cu is 1, O is 2, Cu is 1, and O is 1. So if I put a 2 in front of that, that changes those to a 2. If I put a 2 in front of here, and now it is balanced. Okay, so part 2. It says, after balance the reaction, write down if it is type of synthesis, decomposition, single or double displacement. So I have BaBr2 plus NaNO3 yields BaNO3 plus NaBr. So I've got Ba, Br, Na, N, and I also have an O, don't I? So I'm going to write the same thing on this side, and now I'm going to count. So right now on this side, Ba I have 1, Br I have 2, Na I have 2, nitrogen I have 1, and oxygen I have 3. On this side, I have 1 for Ba, Br is 1, Na is 1, nitrogen is 1, and my oxygen is 3. Like Miss Sloan says, the oxygen says it's fine now, so then I'm just going to look at what I need to balance. So Br and Na is what I want balanced, and so I just need to change that to a 2, which is here, and 1 Br is now 2, Na is now 2, nitrogen and oxygen, and it's balanced. So if I look, it is double displacement, right? Okay, so let's look at number 4. So number 4 says blank Al plus blank O2 yield blank Al2O3. So on there, I have drawn my little thing in between. I have Al and O, Al and O. Al is 1, O is 2, Al is 2, O is 3. And remember, Miss Sloan doesn't like odd numbers, so I'm going to put a 2 in front of here, which causes that to be a 6, changes that to a 4. So then I can go over here and change that to a 4 now, and my oxygens need to be a 6, which is 3, right? And so now it's balanced. So this is synthesis. And remember, you can always go back to the handout that you did where you were coloring everything. If you feel like you still need to color, like I have done on some of my pages, please feel free to color still. Okay? So now what I'm going to do is I'm going to go now to number 5. And so number 5 is SeBr6 plus O2 yields SeO2 plus Br. So SeBr and O, SeBr and O. Se I have 1, Br I have 6, and O I have 2. On the product side, Se I have 1, Br I have 2, and O I have 2. Well, I am smaller on this side for Br. So if I put a 3 in front of there, nope, that doesn't work. Well, forgot the 2. There we go. So if I put a 3 in front of there, that makes that a 6, and now it's balanced. So let's see what we have. We have single replacement is the answer for number 5. Number 6, blank P2O3 yields blank P4 plus O2. 7 is C2H4 plus blank O2 yields blank H2O plus CO2. And I'm going to have you do those by yourself and tell me what types they are. And then let's look at number 8. And it says, for each of the following reaction, predict the product. Do not balance the reaction. So, number 8, I have NaCl, which is an aqueous solution, plus LiCO3, which is an aqueous solution. So if I look, I have A, B, C, and D. Now, when I'm doing these problems, I'm going to probably pull out my markers again, my red, my blue, my yellow, and I think it was green. And I'm going to color because I think that makes me feel better. So, if this is A, then this is B. This right here would be C. And then this one would be D. Right, guys? So if I do my colors, I'll be able to see. I know this is double displacement. So if I want to put my letters, I can. So that is A. Oh, I think I did the wrong colors, but it's okay. B plus C and D. So based on that equation, and let's look at our double displacement that we were doing in our practice. A, C, B, D. So, Miss Sloan, guess what? She did it right. So let's do that again. That's fantastic. I'm so proud of myself. I'm going to go back and look. It's okay if you make a mistake. You can always go back and change it. So based on that, A and B stay by themselves. C and D changes places, right? CO3 and Cl. There we go. I just predicted the product based on the coloring system. So let's look at number 9. So number 9 says C4H12, and it says it's a gas, plus O2, and it says it's a gas. Okay, so we have our A, and this is single displacement, right? This is double. This is single. Remember what single is. Let's look back. Single displacement is A plus BC. Well, we've got A, B plus C, right? So can we do it still? Sure. So let's look at our synthesis again. Let's look at our, we've decided we're going to do a single displacement, A, B, C. So let's say, all right, so let's say this is A, this is C, and say this is B. So to be able to do that, we know that this and this will change its place, right? So we have C4O2 plus H12. Okay, so let's look and make sure that's what we're doing. A, B, and C. So that is A and B and C. And then it changes with the partners. C changes with B. Well, let's see what we did. We changed it. So we look good. So that is the second problem. So you still have number 10, number 11, and number 12 to do. Please make sure that you do that. And I hope you have a good day.